You are building an app. User upload a profile photo. The most obvious thing to do is to show the photo into a column in your users table. Job done, right. It works for about a week. Then your backup gets slow. Your queries get slow. Your bill get weird. And one day, 3 months in, somebody asks, why is your database 800 gigabytes and nobody has a good answer? Here's what you missed. There's a whole separate kind of storage built specifically for files like that. S3, Google Cloud Storage, Azure Blob. Every serious app on the planet uses one of them. Once you understand them, you will stop reaching for the database every time you have bytes to save. 10 minutes, we are covering what object storage is and why it exists and how it pulls off infinite scale. Let's get into it. Here's the one sentence answer. Object storage is a separate storage system that holds big binary files, images, videos, PDFs, backups, addressed by name, fetched by URL, and replicated across many machines so nothing ever gets lost. Let me unpack it. Big binary files, those are called blobs. Opaque bytes, the system doesn't try to understand. Addressed by a name, every file has a key like photo/anita.jpg, globally unique inside its bucket, fetched by URL. You get a real web address back and your app or your browser pulls the files directly over HTTP, replicated across many machines, usually 3 or more copies in different physical locations automatically. The three big ones you will see in interviews are AWS S3, Google Cloud Storage, and Azure Blob Storage. They all do the same job in nearly same shape. Understand one, you understand all three. Stick this in your brain forever. Object storage is a key, a blob, and a URL. That's the whole product. Notice what's not on that list. No tables, no rows, no SQL, no joins, no transaction. You don't query object storage. You put things in by name and get them back by name. Here's a picture that's going to stick. Object storage is the luggage check at an airport. Picture it. You walk up with a suitcase. The clerk gives you a number tag. They take the suitcase somewhere behind the counter. You have no idea where. Maybe a shelf right there. Maybe another building. You don't care. When you come back, you show your tag. They go fetch your exact suitcase, same bag, same condition. That's an object storage, word for word. Your file is the suitcase. The key, like photo/anita.jpg, is the number tag. The bucket is the airport. And the staff behind the counter, that's the S3 or Google Cloud Storage or Azure Blob Storage. Doing the work of figuring out which shelf in which warehouse your bag actually lives on. If the airport gets busy, what do? They add more shelves, more rooms, more buildings. From your seat at the counter, the system looks identical whether there are 100 bags in the storage or 100 million. You walk up with a bag, you get a bag. And nobody is ever allowed to walk into the back and rummage. You can't say, give me every bag that's red. You only ever ask by tag. That single rule is what lets the storage room grow forever. That's the deal object storage makes with you. Give up the ability to query the bytes. Get the ability to scale to a planet. There are 3 reasons object storage exists and you should care about all of them. Reason 1. Cost. Storing a gigabyte of photo in your database costs maybe 10 or 20 times what it costs in object storage. Object storage runs on a cheap commodity disk, optimized for huge cold blobs. Databases are tuned for expensive, low latency operations on a small structured row. Wrong tool, wrong price. Reason 2. Scale. Your database is one machine or a small cluster. Object storage is thousands of machines running as one system. Companies store petabytes in a single bucket without thinking about it. Reason 3. Direct access. Once a file is in S3, you can put a content delivery network in front of it and users around the world pull the file from server near them. Your app never sees the request. Your database never sees the request. The file just gets delivered. This last one is huge. If a profile photo lived in your database, every view would mean a database query. With object storage, the photo is just a URL and the user's browser hits directly. Let's look at this in practice. On the left, the bad version. Your database has a photo column holding the raw bytes of the image. A 4 megabyte image lives in your row. Every backup of your database now drags 4 megabytes per user. Every read of that row drags 4 megabytes. Your disk fills up. Your cache becomes useless because no single image fits twice. On the right, the good version. The database row only holds a URL, something tiny, maybe 100 bytes. The actual photo lives in an object store. When the app needs a photo, it reads the URL from the database and usually hands the URL straight to the user's browser to load. The database stays small and fast. The object store handles the heavy lifting. Now let's look at what the object store itself actually looks like inside. A request to object storage is just a HTTP GET to a URL. The URL has two important parts. The bucket name, that's like the account or namespace, and the key, that's the full path to your file inside the bucket. Inside the bucket, there are no tables, no folder. The photos/anita.jpg part isn't a folder structure. It's just a string. The whole bucket is one giant flat map from keys to blob. Photos, videos, backup, zips, they all sit in the same flat namespace, distinguished only by their key. Underneath, every blob is automatically copied to multiple physical locations, usually 3 or more, across different data centers in the same region. If one disk fails, 2 copies remains. If a whole building burns down, the other zones still have it. This is how object stores achieve 11 nines of durability. The chance of losing your file is so small, it's basically zero. You don't configure any of this, it just happens. And because every blob lives in a flat key space replicated across many machines, the system scales by adding more machines. There is no central index to bottleneck on. There is no schema to lock up. The trade-off is the one we mentioned. You can only ask by exact key. I want to be honest with you about something most courses won't tell you. The good news, object storage is one of the cheapest, most durable, most scalable piece of infrastructure ever built. It's the right place for almost anything bigger than a kilobyte that you don't need to query. The bad news, the trade-offs are real. You cannot search inside the files. You cannot ask, give me all photos uploaded last week without keeping a separate index, usually in your database. Latency is higher than reading from a local disk, and there is no transaction support. If your app uploads a photo and then crashes before saving the URL to the database, you have got a file with no row pointing at it. You will need to clean it up. When not to use object storage, when you need to query the content, when the file is tiny and changes constantly, a 100-byte config that updates every second costs more in API calls than it would in database. Simplicity is a feature. 4 questions this video has set you up to answer. Question 1. What is object storage? In one sentence. A separate system for storing big binary files addressed by a unique key fetched over a HTTP replicated across many machines for durability. Question 2. Why don't you store images directly in the database? Because the database is a wrong tool. It makes backup slow, query slow, and disk usage explode. Store the bytes in the object store. Store the URL in the database. Question 3. How does object storage achieve infinite scale? By being a flat key space, not a relational store. Every object lives under a unique key, replicated across many machines. Adding capacity is just adding machines. There is no schema or index to bottleneck on. Question 4. When would you reach for object storage in a system design interview? Anywhere you have a user uploads, images, videos, logs, backup, machine learning datasets, or large generated reports, any file your users care about that isn't a row in a table. Master those 4 and you will answer the most common "where do I put this file?" questions cleanly. Before you go, take 30 seconds to log this in. Takeaway 1. Object storage is a key, a blob, and a URL. S3, GCS, Azure Blob, all the same shape underneath. Takeaway 2. Don't store images in database. Store the URL in the database. Store the bytes in the object store. Your database, your backups and your wallet will thank you. Takeaway 3. The infinite scale trick is the flat key space. You give up queries on the bytes, you get to grow without limits. That's all about object and blob storage. If this helped you, hit subscribe so you don't miss the next one. The full playlist is linked below. See you in the next video.